So hopefully this works. So I've written down the givens, hiddens, asked for, and now the equations are going to be different for each one. So I'll kind of do them sort of separately in different colors so you can see what's going on. This is a what type of projectile motion problem? Yeah, this is a tabletop problem, right? So you have your cannon thing here, and then boom, lands here. Okay, with this initial velocity of 1,200 meters per second, with this height of 78.4 meters. So remember, make sure you make a diagram. You have to do a diagram for problems. Okay, and then what you want to do is get in the habit of labeling on the diagram, because eventually, like this part, I'm not going to make you do that anymore, but the GHA, all that stuff, but you must have this information on the diagram. Do you see how? So you get rid of this, but you didn't really get rid of it. You just put it on the diagram. So make sure you're labeling your diagram. And basically, when I see people's, like as a class, when I see diagrams labeled and clear and discernible, then we won't have to do this anymore. Okay. All right. Yeah. So if we want to know the time, I write down, first thing I do if I don't know how to do this problem is what? I've done givens, hidden, stuff like that. I have no idea what to do. This is a projectile motion problem. What do I write down? Boom, right away. Don't even think about it. X equals Vxt and Y equals Vyt plus 1/2 AT squared, right? Just right away, boom, I put those two equations down. Any questions on that part? Okay. Which way does the projectile fall? Oh, wait, hang on. I must pull up my stress inducer. All right. Kevin. Yeah, there he is. Stress inducer, Kevin. Which way does the projectile fall? Oh, excellent answer. Good. It doesn't fall forward. It falls only down. Because what makes anything fall? Gravity. Right? So when you say something falls, it only falls down. Unless you're stuck between two large gravitational objects and you're falling in some other angle. But yeah, on Earth, it falls down. So I know that this horizontal velocity is going to stay the same the whole way. If you'll allow me to say that this is the horizontal speed. And we talked about that yesterday, right? Where I said like that never changes, right? It's always going to be the same. The thing that's going to change is the vertical velocity. So what's the initial vertical velocity? That's 0. That's why I put Vy as 0. Is Vy 0 down here? Can I do this? No, that's final velocity, right? This is like Vy final and Vx final. Okay, this one's easy. What's Vx final? 1200. Boom. No problem. Okay, but this one we have to find out. So the time, I'm only going to use the y dimension, right? So I have y. Do I have Vy's initial? Yeah, that's 0. So then I just say this. Y is equal to Vy0 t plus 1/2 a t squared. That goes away. And so I get t is equal to 2y over a, the square root of 2y over a. And of course, I can plug everything in, and I get 2 times 78.4 over, I'm just going to say 10. Now, if I make this negative, then I got to make gravity negative, right? Here I've made, I guess I should have put here, a is 10 meters per second squared. So that's like 157 or something. Oh, that was quick. Oh, okay, cool. So this is square root of like 15 or something. 16? Okay, there you go. So square root of 16 would be 4. So this is going to be around 4 seconds. Okay, I'll do the next one in a different color. Then we want to find x, this right here. Now, Jody, before, what did I tell you you have to do whenever you have a problem with two parts? Find the what? Okay, that's the way to cut straight through all of my shenanigans. Yeah, so obviously she saw where I'm leading her. And where I'm leading her is that we have to find time when we're doing a two-dimensional motion problem. Because you take one dimension where you know something, you find time, then you plug it in the other dimension to get what you're looking for. We already knew the height, so we start with the y, we found time, and now we can go get the x. All right, the bridge, remember the bridge, super important. So here, we found that time, right, to be around 4 seconds. So then that means for this, I can just say x is vxt, right? And do you see what's not here? The plus 1/2 at squared, right? Because there's no acceleration there. So then here I get around 4,800 meters. I'm doing these by approximation, you know, just sort of mental math. I don't know if that's exact numbers. Oh, I think it's exact if you use 9.8.
There you go.
Oh, thanks. Michelle, Brian, Kevin, Michelle, Brian, Kevin, Jordan, and Nandwa. Okay, so that's why they made this number like this, so that when you did this, you'd get an even number. But if you use 10, it doesn't come out right at the end. All right, then we got this part. So now we just need to find final velocity. Again, I'll switch colors so everything's clear for you. We have our givens over here. We want this. So what I'm going to do is I'm going to say, what equation gives me Andrew? Where's Andrew? Oh, there's Andrew. Okay. Andrew, what equation gives me final velocity if I know acceleration and time? Sorry? Okay, so y equals v0t plus 1/2 at squared? Is that what you're saying? Does that give me final velocity? No. So which equation should I use? Because I need an equation to find final velocity. Do you have your formula sheet in front of you? There's only 3 equations on your formula sheet so far that we've paid attention to. Sorry? Oh, okay, cool. Remember, all those years of listening to loud music has ruined my hearing, so you kids, don't listen to loud music. All right, V0 plus AT. All right, so we know that V0 originally was 0. So A, if I say it's 10 and T is that, this is going to be around 40 meters per second. Because it fell for 4 seconds. And then I think you can see how do you, if I know this and I know that this little part is 40. Thank you. And this is 1200. Excuse me. All right, then what is that? How do I find it? Din. There he is. How do I find this? Okay, do we know the components of that triangle? Yes. So what equation, what formula do I use to find that pink line? Okay, and do you guys remember the name of that? Yeah, so just use Pythagorean, right? So V total is going to equal the square root of Vx squared plus Vy squared. And of course, that's going to come out very close to 1200, because 1200 is much bigger than 40. 1200 and change. What does it come out to be? I don't have my calculator with me. Anybody get it? Hello, Yvonne. Plug it in your calculator. What'd you get? What'd you get? Yeah, it's 40. So it's like 1201. Is that right? So basically, it's very close to 1200. So it doesn't drop very much. Is that what everybody else got? Yes, no?
Yes.